Hello friends, welcome to Independent Learning. My name is Raj Shah and in this video we are continuing with the chapter Quadrilaterals. Okay, we are going to learn about trapezium, okay, questions based on them, and also we'll be learning about what is trapezium, what is isosceles trapezium, okay, which they are a type of quadrilateral itself. Okay, in the previous video we saw questions based on rhombus, rectangle and square. Okay, so in this video, we'll be looking at trapezium. So let's get started. So trapezium, okay. So you know what is a trapezium? It is a quadrilateral with one of the pair of opposite sides congruent, sorry, parallel. They are not congruent. So if I name this as A, B, C, D, then I can call this a trapezium if AB is parallel to CD. So what is a trapezium? If one of the side, one of a pair of opposite sides, if they are parallel, then this is called, the given quadrilateral is called a trapezium. Okay. So if there is no other condition for it, neither other sides congruent or angles congruent, no other condition, just considering one side, one pair of opposite side, and they should be parallel. Okay, so I hope you have understood what is trapezium, just one condition. Now what is isosceles trapezium? Okay, so if you draw a trapezium, okay, so PQ RS. Now you already know that this is a trapezium. If this is a trapezium, we know that PQ is parallel to SR. Yes or no? But this is isosceles trapezium. Now you know what is an isosceles triangle? Okay, which is this opposite angles. These two angles are congruent. Then these two if sides are congruent, then angles are also congruent. So this is an isosceles triangle. Same way, isosceles trapezium says that these two sides, they are congruent. So we always take not the opposite sides, not the sides which are parallel, but the other sides, they will be congruent and these base angles will be congruent. Okay. So there is a question based on if these two sides, the opposite pairs, so the pairs of opposite sides, if they are congruent, okay, which is isosceles trapezium, it is formed, then we have to prove that the base angles are congruent. Okay, so you can check that question afterwards in your textbook. Okay, so this is what isosceles trapezium is, with one of the sides parallel and the other pair of opposite sides congruent. Okay, so that is isosceles trapezium. So I'll write it PS congruent to QR. Okay, so one pair of opposite sides is parallel and another pair of opposite side is congruent. So that's what isosceles trapezium is. So I hope you have understood what is trapezium and what is isosceles trapezium. Now we'll solve some questions. Okay, let's see some couple of questions on this topic and we'll end the video. So let's see some questions. So the first one, which says that measures of angles of a quadrilateral ABCD are in the ratio 4, 5, 7 and 8. Okay, so here we can say, okay, show that ABCD is a trapezium. So if you draw a trapezium, or if you consider this same trapezium, okay, exclude these, or let's draw it first. Okay, so A, B, C and D. So these are there. Okay, these are in the ratio 4, 5, 7 and 8. So can we say let the common multiple be x. Okay, so always say that if the angles or the sides, if they are in ratio, multiply x with each of them and say that angle A will be equal to 4x, angle B is equal to 5x, C will be equal to 7x, and angle D is equal to 8x. Okay, so each of the angles we find using these ratios and we multiply the x with each of them. Okay, because they are ratio means division. Okay, 4 upon 5, it can be like this also, 16 upon 20. So 4 upon 5 can be 16 upon 20. That's why it's ratio. So 16 upon 20 can be written as 4 upon 5. That's why we don't know what number is there here. That's why multiply this with x and x. So that whatever multiplication you get, that will be your answer, which will give you the actual this. Okay. So you might have learned this in ratio and proportion also in your algebra. Okay, so you can check that. So here ABCD will be this. Now we know that this is a quadrilateral, and you know sum of the angles of a quadrilateral is 360. Therefore we can say C plus D is equal to 360 degree. Why? Sum of angles of quadrilateral. Yes or no? Therefore put all the values in this. Let's see what we get. 4x plus 5x plus 7x plus 8x equal to 360. Add this. 4 plus 5 9 plus 7 16 plus 8 24. So 24x is equal to 360. Okay, so x is what? 360 upon 24. Yes or no? So this will give you 2 and 30. 30 upon 2, which is equal to 15. Okay, so x is what? 15. Now how can we get A, B, C, D? So we can get angle A is 4x, so 4 into 15 degree, so that is 60. Yes or no? So angle A is 60 degree, like this. After finding x, substitute in each of them, you get the rest of them. So angle B will be 5 into 15, so 75. Angle C is 7 into 15, so 105 degree. Angle D is 8 into 15, so 8 into 15 is 120. Okay, so this is what we have got. Now just put this here, 60, 75, 105 and 120. Okay, so after finding the angles, what are we supposed to prove? Prove that this is a trapezium. So to prove that this is a trapezium, what are we supposed to actually prove? That one of the sides is parallel. Yes or no? That means AB should be parallel to CD. Okay, this is 105. So AB should be parallel to CD. Now if you see, can we add these two, 60 and 120? Isn't it forming an interior angle? Yes or no? If I see, like if you see A plus D, angle A plus angle D, if you add this, okay, 60 plus 120, it is giving you 180. What is this condition? A plus D is giving us 180. That means the interior angles ka sum is what? 180 degree. That means by interior angle theorem we can say that AB and CD, they are parallel. Yes or no? Why? Because if the lines are parallel, then the sum of the interior angles is 180 degree. That is interior angle. But converse interior angle theorem. So if you are getting confused with this, please check that video, okay, before continuing this. Go check that out and then you'll understand it better. So converse interior angle theorem will be applying here. Therefore, we can say AB is parallel to CD. This is parallel to this by converse interior angle theorem. Okay, so you can write that because it is forming like this. So interior angle, see this angle and this angle the sum is 180. So we have got, so one of the pair of opposite side we have got as parallel. Now so can we say that this is a trapezium now? No. Why? Let's check the other two sides also. If they are parallel, then it will become parallelogram. So we have to show that these two are not parallel. So let's add 120 and 105. So here, what are we getting? If you add 120 and 105, you get 225. 180. We want 180 here. So that's why we say that 225 is not equal to 180. Therefore, if D plus C is not equal to 180 like this, then we can say that AD and BC are not parallel. So AD and DC are not parallel. Therefore, from this we get only one pair of opposite sides parallel. Therefore, ABCD, we can say that ABCD is a trapezium. Okay, so I hope you have understood this. Now let's take another question. It says, so this is given to us. The trapezium is given to us, and what are we supposed to do? ABCD is given. This and this, they are congruent. What else is given? BC is parallel to AD and BA is congruent to CD. Okay, we have to prove that ABC is congruent to DCB. So this angle and this angle should be congruent, we have to prove. Okay, so to prove this, we'll do a construction. Okay, we'll do a construction like this. We'll draw AC, diagonal AC, we can say. Draw diagonal AC. Okay, so after drawing this, let's see the proof. Consider these two triangles. So this can be done similar to how we did in triangles. Okay, we can prove that these two triangles, they are congruent. Sorry, what did we do? So here this is not necessary. Okay, we can do it like this. Here we have to prove that this angle and this angle, they should be congruent. Okay, so if these two angles is to be proved that they are congruent, we'll have to prove that these angles are congruent first. Angle A, which is BAD, and CDA should be congruent. If we are able to prove these two angles congruent by interior angles theorem, we can prove that B and C, they are congruent also. So let's see how we do it. For proving these two to be congruent, we'll do a construction which is done like this. Okay, sorry. So draw Okay, what are we doing? We are drawing CZ, okay, this such that it is parallel to AB and also AB is congruent to CD. Also the length is congruent, okay. So this length and this set CZ, it is congruent. So if you see, okay, so let's see, okay. I hope you have understood the question. We have to prove that these two angles should be congruent. But to prove these two angles to be congruent, we'll prove the base angles to be congruent. If we are able to do it, then we can also say these angles are congruent. So we'll see how we do it. For that we did this construction, okay. Now in quadrilateral A, B, C and Z, okay, A, B, C, Z, AB is congruent to CZ, AB is congruent to CZ, correct, and AB is parallel to CZ, correct. So if AB is parallel to CZ and CZ, they are congruent also and parallel also, can I say that quadrilateral ABCD is a parallelogram? Yes or no? Because you remember, for a quadrilateral to be a parallelogram, we just need to prove that one of the pairs of opposite side is parallel as well as congruent. Okay, so we have done that. Now this and this, again we know that this AB is parallel to CZ, AB parallel to CZ, and AZ is the transversal. Okay, so what are we getting here? This AB is parallel to CZ and AZ is the transversal, or you can say AD. So we are getting something like this. This is B, this is A, this is C, Z, and this is D. So if AB and CZ, they are parallel and AD is the transversal, can I say this angle and this angle, they are congruent? Yes or no? Why can I say this? Because these two angles are forming corresponding angle. Yes or no? Corresponding angle. Therefore I can say angle BAZ is congruent to angle CZD. The reason? Corresponding angles test. Okay, so these two angles we have got as congruent. Now if you see, okay, now here BAZ, okay, this angle BA is congruent to CD, okay. So this angle and this angle we have got as congruent, but if you see, this is congruent to this here from the sides. AB is congruent to CZ, okay, and we have drawn AB is congruent to CZ, sorry, where is it? That is the construction, and AB is congruent to CD, yes or no? So here this, let's name this as 1 and this as 2, okay. So AB is congruent to CZ from construction and AB is congruent to CD, which is given already. So from 1 and 2, can we say, okay, can we say from 1 and 2 that CD is congruent to CZ? Yes or no? CZ and CD, they both will be congruent. So we can say the reason from 1 and 2, correct. So from these two we get CZ and CD congruent. This and this will be congruent now. Okay, so actually all the three lines are congruent. So here if this is forming a triangle, so in triangle CZD, okay, opposite angles are congruent, therefore the sides, sorry, opposite sides are congruent, therefore the angles will also be congruent. Yes or no? Therefore angle CZB is congruent to CDZ. Yes or no? So this angle and this angle, they will be congruent by isosceles triangle theorem. Okay, so we get these two angles congruent also. Now here let's name this equation as 3. This, okay, BAZ, AZ and CZD, they are congruent, and also CZD and CDZ. Okay, so let's name this as 4. Now if you see from 3 and 4, can we get CZD, CZD? They both are there in both of them, correct? So BAZ can be congruent to CDZ, therefore BAZ is congruent to CDZ from 3 and 4. Yes or no? So I hope you are understanding where are we approaching. So here we are able to prove that BAZ, so BAZ is congruent to CDZ. That means this angle and this angle, they are congruent. So we can say this as BA, instead of Z we can say BAD. Okay, so BAD is congruent to CDA. What will be the reason for this? Same angle but different name, correct? So this is what we have got, and that's why we get BAD is congruent to CDA. Okay, so I hope you have understood this till here. So we have proved that the base angles are congruent. So there is a separate question on this, so this can be asked in as a separate question also, but here the question here is this angle should be congruent to this angle. So let's see how we do it. Now for these two angles we can say angle ABC plus angle BAD is equal to 180 degree. Yes or no? This angle plus this angle, they are forming interior angle, therefore their sum is 180 degree. So we can say interior angles. Okay, so for getting interior angle, corresponding angle or alternate angle, we just need to have lines to be parallel. Here this is a trapezium because BC is parallel to AD already given. So if BC is parallel to AD and AB is the transversal, then we can get these two angles to be interior angle. Same way we can get this angle BCD and ADC also as interior angle. So first of all let's take this. Now BAD, what is BAD? Sorry, ABC, right? So this is what we need to get. ABC is equal to 180 minus BAD, correct? This is what we get from this. Now let's take these two interior angles. So it will be BCD plus CDA is equal to 180 degree, correct? This angle plus this angle. So again, interior angles, correct, are supplementary. You can complete that. Therefore, what are we supposed to find? BCD. So keep the BCD here equal to 180 minus CDA, correct? So we have got this and this. Let's name this as 5, equation 5. Now we have to prove that ABC should be same as BCD or DCB, same thing. BCD or DCB, ulta or seedha, it is the same thing. Now, if we want to prove these two, 4, 5, this equation and this equation to be same, we need to prove that these and this should be same. But we already have, see, BAD and CDA, they are congruent. So let's name this as 5 and this as 6, okay, and this as 7. So here this will be 180 minus BAD from 5 and 7. Yes or no? Because from 5 BAD is same as CDA. So here in this, in 7, 180 is equal to 180 minus CDA. Instead of CDA we can write BAD. Correct? So this equation 6, and let's name this as 8. So from 6 and 8 we can say that angle ABC is congruent to BCD from 6 and 8. Okay, so this is what we had to prove here. Okay, so I hope you have understood this. We had to prove these two angles to be congruent. So we tried to prove these two base angles to be congruent first, and then we did interior angles test and we proved that the above the other two angles are congruent also. Okay, so I hope you have understood this question. Okay, so this is it from my side on this topic, trapezium. Okay, so I hope you have understood this video. Now in the next video we'll be continuing with the chapter again, and we'll be taking the last topic, which is midpoint theorem. Okay, so see you in the next video. I hope you have understood this video. If you have understood it, make sure that you share it with your friends. Okay, thank you for watching.